I've got it right in front of me, but I was just saying hello. Right, we've got a recording running. We're still short of a couple of people who are usually in attendance. So give it a minute or two, just to make sure we don't. And let's begin. Morning, everybody. I know for certainty that over the last many weeks, I have been talking about a lot of things, all little bits and pieces of things, from the conversion of DDS to DDL, i.e. getting into the SQL paradigm on the physical tables. I've been talking about constraints, I've been talking about triggers, I've been talking about I/O servers, I've been talking about a lot of things. And all of them have tended to be in a little bit of isolation, because unfortunately we cannot discuss everything all at once. What I'm going to do this session, and possibly even a little bit of next session, is I'm going to now try and stitch everything that we've covered together. And it's quite important for me to make sure that this gets done properly, is that I need feedback from you guys, either during the session or by email afterwards, so I can close the loop next Tuesday. So that the whole idea now is to try and get all the pieces that have been floating around in a sort of a limbo and pull them all together to show you exactly how the pieces drive the whole modernization paradigm. So I'm going to start by picking up where I left off with, I was talking about two types of modules. Now I'm going to go and just find my code. Most of this will be code. I don't have many slides at all for this particular part of it, because most of it is going to be looking at actual, real, working code. I tested it all and it worked at 2:30 this afternoon, so one hopes that it will continue to work while I demonstrate it. But we're going to be looking at actual, real code. The first thing I want to look at is I want to look at our little, where are we? We had a little database here, a little AO database, which is going to become the subject of 4 sessions, a little further down the line, from relational data on their one-point portal and how you build front ends. So I'm not building front ends here. I'm taking the database, and in particular today, I want to look at these 3 files here. The customer master file, the customer balances file, and the customer address file, which we created in a normalization process to separate out the master file, which is the basic customer information, the address file, which is multiple addresses for a particular customer, so there's a one-to-many relationship there, and then the master to the balances, there's a one-to-one relationship separated because of the volatility of the balance file compared to the other 2. So it's those 3 in particular we're going to be looking at. So I'm coming back and starting at the end, really, where I talked to you on Tuesday about 2 types of modules, the cycle main module and the linear main module. And the main difference between the 2 is the RPG cycle. In the cycle main module, you have an RPG cycle included, which is then opens your files and does all of those things that the RPG cycle used to do, most of which we don't use anymore. And that particular type of program construction is really I believe it should be on its way out because we don't use the cycle. Let us rather eliminate the unseen code, and then we can begin to work in a modern paradigm with code that you can physically actually see, i.e. you do your own opens and closes, and so on and so forth. So I chose as an example of what one does with this, I chose the before trigger for the customer master file. Now that is the code that we are looking at now here on the screen. It was constructed and it was originally written as a cycle main module and then compiled using create-bound RPG as a RPG4 program, executable program. We know that a trigger program is called from the database management system in a similar way to the way you would call any program from any other program. As a result, it's a callable program, or it's a called program. And you can see here it has an input fully procedural file. It has some specs to control its activation group. Default activation group no, i.e. we do not want the trigger to run in the default activation group. We want the trigger to run in the activation group of its caller because it has to run in the same activation group as its caller. So the trigger is designed that way and is specified this way. All the code you can see here, the first /free, and the monitor is the beginning of the main line, if that term still exists, I'm not sure. And the main line extends to that point, and so that is the main line of the program. That is the calc specs, the body. What happens after that are various different procedures, as we have discussed going back a long way. These procedures replace, in all modern RPG, these procedures replace subroutines. We don't write subroutines anymore. We write procedures. There's major benefits to doing that, not the least of which is its local and global data definition capability. So this program was written as a cycle main module, and it was then compiled as a program, making it a cycle main program, i.e. it had the RPG cycle built in. What I did was I created a duplicate of that program, and I converted it to a linear main module, i.e. I changed it to drop the RPG cycle out of the trigger. Why? Because a trigger doesn't really need an RPG cycle. And it's quicker and more efficient, and it works better if all the RPG cycle code is removed from trigger programs. And it's this technique, you can convert any program from a cycle main procedure or module to a linear main module using exactly the same technique. It's not complex, it's not over the top, it's not highly risky in any way at all. So what I'm just going to do is take you through the steps to change the 1B0, which is the cycle main module, into B1, which is the linear main module. And the first thing you do is you add that HSpec. Now, that is the main line definition, and it names the procedure that is going to be used as the call or the program entry point. Now, typically, that is the name of the program, because if you start changing, you can have a different callable procedure or program entry point, can have a different name to the name of the program itself. But if you start doing that, you confuse yourself beyond belief. So the important thing is to try and maintain a completely standard naming convention and never deviate from the source name and the program name, and now in terms of the linear main procedure. That main procedure is the first procedure in the program. Now, in this previous one, we had here from this monitor here down to this return, or the free to the end free, from there to there, as the main line. What we do in this program is we create that main line as a procedure. You can see it's got the name, B1. It has a parameter interface, which is exactly the same as the parameter interface we defined up here. But now that parameter interface is defined within the within the procedure that is considered to be the linear main procedure. So we've created a module. You can see it starts at a B there and ends with an E there, and everything between those two is identical to what it is here. There's the PP, and everything between the two is identical. So all we've done is we've taken the main line of the cycle main module, and we've turned it into a procedure within the linear main module, and then we've identified that procedure by using the main keyword as the program entry point. Essentially, that is the only change that is necessary. You will notice that the PI, or parameter interface, that was up the top of this program is gone from there, because it's now down here defining the parameter interface of the procedure. But it's still there, it's just moved. We still have the F-spec, because even though we are not using the cycle main module, we're using a linear main module, the F-spec is part of the file definitions in the global data definition, and the only thing you have to add to this one is you need to define it as a user open. Previously it wasn't. Now it needs to be defined as a user open because it is not automatically opened by the RPG cycle. So you have to open it. This, by the way, is not the master file. We got the master file. The trigger is the master file trigger. This is a balances file, which is going to be used by the trigger. It's not the master file to which the trigger is attached. Right. Other than that, your parameter pointer and your definition of your parameter list remains exactly the same. Your original record pointer, original record itself, the new record pointer, and the new record remain exactly the same, no change. Your error handlers remain without change. So do the various prototypes for the sub-procedures that are inside this procedure, and together with an error indicator and a username. That's all exactly the same as it was before. So the change, and let me go past this procedure to the first default, the first sub-procedure after the main line, which is the default. And the code in both these programs from this point to the end are identical. Completely identical. Nothing has changed. So the ability to change a cycle main program into a linear main program is actually very simple. It makes the programs more efficient. as long as your code doesn't depend on the RPG cycle, and that you've got to be very sure of. If people are not using the cycle consciously, then the only things that usually depend on the RPG cycle are the opens and closes. Right, let's just have a quick look at this trigger and see what it's doing. It goes in an insert, it has a default routine, it has an insert event, and it has a validate. In the delete option, it has a delete event, and in an update option, it has a default update and a validate event. Now, one of the things about having triggers that open files, that have files that are user open files, is that if you don't need to use that file, you don't need to open it. As a result, it can be much more efficient. So if we have a look here at this trigger, which is essentially the same event here is the delete event. And I told you a little white lie there. The code is not identical. I only need to check the customer balances file if I receive a delete request. Therefore, I only need to open the customer balances file if I have a delete request, which means that the delete event will check. If the file is not open, then open it, in order that I can chain to it and check its balance before throwing it out as an error or not, as the case may be. That is a variation. Those 3 lines of open of that file occur there because that file only needs to be checked during the delete event. So if you're doing inserts and updates and no deletes, then that file will never be opened, which makes the whole process smaller, the PAG smaller, and as a result, everything more efficient. But other than that, the update event, make sure that the new date stays the same as the old date. We've already discussed that. And on the insert event, to put in the date, today's date for the insert, because that is the start date for that customer. So that is the conversion of a cycle main program to a linear main program. And it is genuinely, obviously, the smaller the programs and the more compact and procedurized your code is, the easier it is to make these conversions. But I would recommend that if you start writing new RPG programs without specifically wanting to use the RPG cycle, you write them as linear main modules, just to eliminate the extra bunch of code and the overhead that goes with it. And obviously, you can make any procedure in your program the program entry point. I would suggest you make it the first procedure that you define. Nothing forces you to do it, but there's a standard that I hope you're all scribbling down furiously, to say, if you're going to use linear main code, please make sure that you use, your main procedure, your program entry procedure, actually is defined as the first procedure in the program. If you stop doing that, or if you don't do that, you can make it very difficult to actually find out where you are at any particular point in time. And always name that first procedure, that PEP, program entry point, as the name of the program. Now, this particular program compiles in exactly the same way as you would compile this one. The actual compile statement is identical. You don't have any parameters because the most important parameter is that one there, which is provided on the HSpec. Other than that, the compilation is exactly the same. So low risk, simple to do. Obviously, if you have a main line of 50,000 lines of code, then one has to first examine the possibility of reducing that program to multiple smaller modules before you start tackling this type of thing. Okay, I'm going to also just show you the after trigger, which is another element in here. And I did exactly the same thing with this after trigger. I added the main statement there. I moved the PI down to the procedure. There's the mainline procedure. There's the beginning of the procedure. There's the end of the procedure. That's the main line in the program. Here, after the trigger, we have an insert of a balance file. And here I'm using an actual I/O server. So I don't even have an FSpec for that balance file here in the after trigger, using an I/O server instead. So there's a slight variation there. Other than that, no delete, it's only a before insert. Now, in order for you to see what AO does, I'm getting a rainstorm coming down. I hope I don't get lightning. I'm just going to show the triggers. And you can see from an AO workbench perspective that there is one trigger there. It is the A1 trigger, which is the new one. It's attached after insert to the customer master file. There are then the three before triggers: before delete, before insert, before update. B1s attached to the before trigger, as before trigger to the customer master file. So they will action appropriately as we update the customer master file. Now, the way I want to actually show you how this all works is I'm going to use the RDI debugger. It's the way I test all my code, and I find it the most useful testing tool. So the first thing I'm going to do is I'm going to show the constraints as well, so that the customer master file, as you can see, has got a constraint which is a referential constraint to the rep master file, because the customer master file has a rep code on it. And so we have that constraint in place on the customer master file as well. Now, this is where, in a lot of cases, people get seriously confused and lost, because there's a lot of things that happen under the covers when you start putting these elements together that one is not immediately aware of. And as time goes by and as you get more practice, you will begin to understand, and you'll be able to read from what you're looking at here on this screen. You will be able to understand that there are three triggers that are called before the update, one after the update, and so on and so forth. So this is probably what most confuses people, and is the things that seem to be happening out of control, unknown. And that is why using the debug functionality of the RDI allows you to actually follow it right the way through, and you can actually see what is happening. And that is what I want to do now, is I want to take, I want to take the program that I created as a test program, and I want to take it through the entire insert procedure. We can do other procedures later, but I want to take it through the entire insert procedure of a record into this customer master file to see exactly what happens and where it happens. Remember, we also have, and I will just put it up here, we also have an I/O server program which manages the I/O processes for the customer master file. And we have an I/O services program that also manages I/O for the balances file. So you can see all the little pieces. Now I want to show you how they're tied together, to show you how I do my testing to make sure my database is working properly before I even climb in to create a user interface. Now, you can create a user interface for a file using display files, UIM, or hopefully the one-point portal that we are going to be showing you in the next little while. But you need to make sure and you need to test that the database is doing its job. And that's what this is all about, is how do I test to see that the database is doing what it's supposed to be doing and that all the ducks are in a row and all the I's are dotted and the T's are crossed. And when I do this exercise, I use a simple little device called a file test program. It's here. And I'm going to just move the SQL statement so that on the right-hand side is the file, and on the left-hand side is my file test program. Simple. Again, it's written as a linear main procedure. There it is there. It's called cust_test. Just because I called it that, I suppose I should have called it cust_mst_test, but doesn't really matter. It's got a name. Now, the first thing that you need to notice is that this default activation group says no, i.e., I do not want this test program to run in the default activation group. I want it to run in a new activation group, i.e., a system-generated activation group. Why? Because while I'm testing, I don't want the fuss and bother of, if the test fails, having to do rollbacks. If, oh boy, that wasn't very, very good. I hope that goes away. I don't want to have to do rollbacks. I don't want to have to make sure my files are closed and neat and tidy. So by using a new named activation group or system-generated activation group, when that activation group closes, all resources are recovered. And that is why I will use, when I'm using my test programs, I will use activation group *new. Obviously, when you implement this functionality, you will have to decide whether you're going to use *caller, *new, or a named activation group, depending on what you want to achieve. But for now, as we discussed on Tuesday as well, you can use *new. That means when you exit that activation group, automatic recovery takes place on all resources, and you don't have to tidy up after you. I created a binding directory called AMW Services, and that contains 1 or 2 service programs that are used by the Advanced Modernization Workshop. But then I discovered there was one other procedure that I needed that was in my services binding directory, so I added that to this one. Not the best practice in the world, I might add, but at least it allowed me to have access to the procedure without having to update AMW SRV. So I can do that as long as you're very careful not to present your compiler with duplicates. That's the important thing. Okay, so we have a prototype for the test program. I'm going to stop here and just ask. Oh, okay. Sorry, guys. Marinus has just prompted me. We're having a thunderstorm that is brewing here. That's why I said, oh, gosh, I hope that goes away. There's a thunderstorm building up here. I'm going to keep going as long as I can, but if we start getting lightning strikes, as we explained right at the beginning, I'm going to have to cut it short. So hopefully we can catch up later or roll it over a bit longer, but I can't afford to risk my comms and computer equipment with lightning flashing around this end. So please bear with me if I have to terminate rather abruptly. Right, there's the prototype definition for the main line, which is there. In this particular case, this is a test program. It does not have any parameters. I'm just going to run it, and I'm going to hard code the different things that I want to test. I have defined here, I've defined the I/O server for the customer master file. I'm going to use that to either insert, update, delete, or whatever files. That is my I/O action and all the parameters and fields that I need to drive the standardized I/O server. I have the error handler, which is a percolation error handler, which simply will take any errors I get out of this and it will pop them upwards to the caller, which is going to happen to be the command line. So I'm going to call this program directly from the command line. Right, first thing we do with a program, I talked last Tuesday about what I called or usually call a function driver. A function driver is the main program in a series of programs that executes a complete function. And it is that function driver that should have its own activation group, either new or named. And in order to activate the commitment control cycle for that activation group that you are just creating with this program, I have a little utility called CMD command, which is in fact a procedure buried inside a service program, which eventually uses qcommand_exec to execute commands directly from RPG. As a result, by issuing a command, start commitment control start change, I can actually use that command to run the start commitment control command and activate the commit cycle for this new activation group that I have asked for here. So this program will create a new activation group, a system numbered activation group, and will start the commitment control cycle for that activation group. So I'm now in my own little box. I've wrapped up into an activation group this little test procedure. I then wrote down all the fields from the file that I was going to need to populate. Customer number I don't need to populate because that is provided by the I/O server as the next number on file. Start date I don't need to provide because that is provided by the trigger on insert. User ID I don't need to provide because that is provided by the trigger on insert or update. And record status is a field that is not being used, so it is maintained as blank by the trigger, so I don't have to provide that for the insert either. With apologies to Everett Express, yours is the name that first came to mind. I populate customer name with Everett Express. I throw in a telephone number, which I promise you is not Everett's telephone number. and I've chucked in a rep code of 44. And in fact, those are the only 3 fields in this particular case that would need to be provided by the interface. Because all the others, the other 4 fields, are actually dealt with either by the I/O server or by the triggers. Now, I have quite deliberately made a mistake here. Rep code 44 does not exist on the rep code master file. As a result, we are going to generate, the first time through here, we are going to create a constraint failure, because I will be attempting to insert a customer specifying a rep code that is not defined in the rep code master file. And that will fail. And I wanted to do this deliberately so that you could see quite clearly where that action occurs in the whole grand scheme of things. Because it's important to understand the sequence of events that occur through this whole process in order to be able to understand what you can do and where you can do things to make it all work very nicely. Thank you. So having populated those 3 fields, I then call the I/O service with an insert request for the customer master file. If that fails, if that call fails, my next executable statement will be this error handler, which will percolate the error up to the top. It will then return, closing the activation group and rolling back any changes that were made to the database. If this is successful, then the commit will be executed and the test program will return, exiting the activation group and closing all the files down. So in either case, I do not have to tidy up after me because I'm in an activation group that is star new and it's going to tidy up when I leave it. Even if I leave it with an error or if I leave it without an error, it will tidy it up. So that's a massive benefit because you can get rid of lines and lines and lines of code by utilizing these functionalities. Okay, how are we going to test this and see how it works? Well, what I'm going to do is I'm going to make sure I'm going to get out of here and I'm just going to find myself a command line and I'm going to display the library list. And you can see here that I have a library list that's got AMWDB under QTemp at the top of the library list. And the subsequent stuff is the AO libraries that are of no concern. We're working with AMWDB. So what I'm going to do with this command line is I'm going to issue a call to CUSTEST. That is what I'm going to do. I'm going to execute that call in order to actually run this program. But before I do that, I need to activate the interactive debugger on RDI. And the way you do that, let me float this remote thing. I'll put this in a detached mode. Where am I? Here we are. Sorry, detached. Sorry, trying to, right. Here are the source files that I've been talking about. And there is the cust test. Now, I can do it either with the object or with the source file. It doesn't particularly matter where I choose the name. Right-click on it, and then I say debug service entry, set service entry point. It will pop up a service entry point. Generally, it's populated exactly as I want it to be, and I will click OK. Now, what happens is that you will get a tab appearing somewhere in your workspace. I usually keep it at the bottom. IBMI service entry points. And it will show an entry there. AMWDB, cust test, program, module, procedure, user, etc. And enabled, yes. This is the service entry point that's been enabled in RDI. Now, RDI is watching to see when this program activates. The moment this program activates, RDI will kick into debug mode. I hope. Sometimes this works, sometimes there needs to be reset. So let's have a look here at my call here, and I'm going to just press the enter key here. And it didn't stop. Oh, this is infuriating. So if you give me 2 minutes, I'm just going to reset this thing. Take a little bit of time. Sometimes I've been doing this all afternoon, so I've got too many instances, I think, I've got too many instances of the debugger active, which is why it's giving me this trouble. I'm actually just going to get to okay, that should be fine. But I'll tell you what I'm going to do for the moment. I'm just going to escape this so that I can start RDI again. I'll come back to the PowerPoint if I need it. Sometimes RDI clutters itself and gets confused, so we have to tidy it up and get it back into a... Right, hopefully I have managed to achieve that. I'm now going to once again set the service entry point. Comms is running a little slow, probably due to the storm. Are you hearing me clearly? Right. Okay. Right, there you have your entry point set. Now let's have another shot at it to see whether, in fact, I've got something there that's in the way. All right. There's call cust test, and I'm going to hit the enter key, and this time it will kick in the debugger. RDI automatically switches into debug mode. I'm going to remove this screen because it's not going to do anything now at all except sit there. I have my program cust test. Here is the cust test program. It's currently at the top of the call stack. The blue arrow gives me the current line on which the debugger stopped. It will always stop on the first executable. And I can now use the arrows here to step through the process. Step into. So what I will do is I will click that button, and it goes to the monitor statement, and then it goes down to the start commitment control statement, which I'm not going to step into. I'm going to step over because this is a very old procedure, and I know it works. So I'm just going to step over it, and it takes me to here. Now I'm going to highlight and monitor the customer master record. I think I can throw it over here somewhere so that you can see it. That is the current contents of the customer master record. I'll tell you what I'm going to do. I'm going to attach this monitor, and I'm going to put it down here so that it is visible to both of us, to everybody. There we are. Now I'm monitoring the record that is actually going to be the customer master record. The blue arrow is on the name, so if I step, I will see what happens with the monitor. If anything changes in the monitor, it goes red, and you can see it's updated customer name with Averitt Express. Step again, it's updated the phone number, and step again, it's updated the rep code to 44. As you can see, the customer number is full of nonsense, and there's no start date, and there's no user ID. But now what I'm going to do is I'm going to step into the I/O server using the step. Guys, I'm sorry, this storm is getting very close. That was a flash of lightning. I think I'm going to have to ask your indulgence and put an end to this session right now before I lose something. Please forgive me. This is the first time ever that this has happened. I will pick it up next Tuesday and carry on, but I don't want to go too deep into this and have to actually restart it. I would rather come back to the beginning of the debug and start it again. I hope that's all right. Please forgive me, but there's lightning coming down, and I'm going to get, I'm very nervous at this particular moment. So thanks very much. Sorry for this. I will see you next Tuesday. Thank you.